Hi everyone, in this video we're going to be dilating an equation of a line. First, we're going to be writing the equation of lines after a dilation when the center is not on the original line. So here in example 1, the line y equals 2x plus 2 is dilated by a scale factor of 3 and centered at the origin. Remember, the origin is 0, 0. So first, what is the slope of the line? Well, let's count the boxes. We're going up 2 and over 1, so our slope is 2. B, what do you think will happen to the position of the line when it's dilated? Well, I think it'll definitely move somehow. C, we want to dilate the following points from the line by a scale factor of 3, and we want to plot the coordinates. So remember, when we're dilating by a scale factor of 3, since we're centered at the origin 0, 0, we can multiply the points by 3. So negative 2 times 3 is negative 6, negative 6 comma negative 6. Negative 1 times 3 is negative 3 comma 0. And 0 comma 2 multiplied by a scale factor of 3 is 0 comma 6. And we want to plot these points. So here is the line. What do we notice about the new line? Well, this new line is parallel to the original line. When something's parallel, it has the same slope. So the slope is going to be the same as the original, which is 2. What's the y-intercept? The new equation is going through the y-axis at 6, so that means my y-intercept is 6. So put that together, my new line is y is equal to 2x plus 6. So remember that we started with the equation y is equal to 2x plus 2, and after we dilated by a scale factor of 3, we ended up with y equals 2x plus 6. So what changed? Well, my slope stayed the same, it remained as a 2, and the only thing that we had to do was take that y-intercept, 2, and multiply it by that scale factor of 3 to give us 6. So what do you notice about the slopes of the original equation, the pre-image, and the new equation, the image? It has the same slope. If two lines have the same slope, we say they are parallel. A dilation creates a line that is parallel if the center is not on the line. The slope stays the same, and the y-intercept is multiplied by the scale factor. So again, looking at this line, 0, 0 was not on the line, so all we had to do was take that y-intercept of 2 and multiply it by the scale factor of 3 to get y is equal to 2x plus 6. And that is how we find the equation of a line after dilation when the center is not on the original line. Now let's write the equation of lines after dilation when the center is on the original line. So for example, we have y equals 3x is dilated by a scale factor of 2 and centered at the origin. That origin is 0, 0. So what's the slope of the line? So let's look. Let's count the boxes. We go up 1, 2, 3, and to the right 1. So that means my slope is 3. What do you think is going to happen to the position of the line when it's dilated? Maybe it'll move, maybe it'll be parallel, or maybe it will stay the same. So let's take a look. We're going to dilate the following points from the line by a scale factor of 2. And we're going to plot the points. So remember, we're going to multiply everything by 2. And then we're going to plot those points. After plotting those points, it appears that the line has stayed the same. So D, write the equation that represents the image of the line after the dilation. It's going to be the same line, y is equal to 3x. So a line remains the same if the center of dilation is on the line. So when we're dilating a line, if the center is on the line, then the line remains the same. Unlike in the last problem, the center was not on the line, so what we had to do was multiply the y-intercept by the scale factor. So here are our two options. When dilating a linear equation, there are only two options. Option 1, the same exact equation when the center of dilation is on the line, or option 2, when the center of dilation is not on the line is parallel, meaning it has the same slope, but the y-intercept, which is the b value, is multiplied by the scale factor. We're going to use our graphing calculator and our table to be specific to check to see if the center of dilation is on the line. Let's take a look at an example. The line y equals 2x minus 4 is dilated by a scale factor of 3/2 and centered at the origin. Remember, the origin is 0, 0. Which equation represents the image of the line after the dilation? So here we have a few questions to break down. So the equation of the line we have is y equals 2x minus 4. What's the center of dilation? Again, it's at the origin, which is 0, 0. So we have to figure out, is the center of dilation on the line? So what we're going to do is check our graphing calculator. So I'm going to type in y is equal to 2x plus 4. Then I'm going to go to my table. Is 0, 0 on the line? No, 0, 4 is on the line. So that means that center is not on the line. So if it's no, then we're going to multiply the y-intercept by the scale factor. So the y-intercept is negative 4. I'm going to multiply that by 3/2, and I'm going to get negative 6. So my new equation is y is equal to 2x. It has the same slope, but a different y-intercept, negative 6. So y is equal to 2x minus 6. Let's look at another example. The line y is equal to 3x minus 1 is transformed by a dilation with a scale factor of 2 and centered at 3, 8. The line's image is, so same procedure as before. The equation of the line is y is equal to 3x minus 1. What's the center of dilation? It's 3, 8. So is the center of dilation on the line? We're going to check our graphing calculator. So I'm going to type in our original equation, y is equal to 3x minus 1. And we're seeing, by looking at the table, second graph, if the center of dilation, 3, 8, is on the line. Yes, it is. 3, 8 is on the line. So I'm going to circle yes, and therefore it's the same exact equation, y is equal to 3x minus 1. Remember, for these questions, we have two options when dilating lines. Option 1, it's the exact same equation when the center of dilation is on the line. Or option 2, when the center of dilation is not on the line still remains parallel, the same slope, but the b value, the y-intercept, is being multiplied by the scale factor.